Welcome back to che205. In this video, I'll be talking about chapter 9 of the textbook, that is on linear programming, nonlinear programming, nonlinear equations, and nonlinear regression using Solver in Excel. Okay, so let's start talking about linear programming. Linear programming is nothing but optimization. Let's say you want to optimize a function, which is, let's say, a function of two variables, x1 and x2, and you have some constraints, and you want to optimize that function subject to the constraints. So a good starting point would be an example. Let's look at a very simple mathematical equation. Let's say I want to find the maximum of this function, 2 times x1 plus 4 times x2. Okay, and I have two constraints. I need to have x2 minus x1 to be less than 4, and then x1 plus x2 to be less than 8. Given that these two conditions must be satisfied, I'm interested in finding the maximum of this function, right? For example, like x2 could be 4 and x1 could be 0, right? So 4 minus 0, this is 4. And then 4 plus 0, that is also 4, so that's less than 8. This is less than 4, so 4 and 0 both satisfy these two constraints. And then it gives me the maximum value of 2 times 0 plus 4 times 4, 16. Well, I don't know if this is maximum, but at least for this specific set, which means x2 equals 4 and x1 equals 0, I found this y to be 16. But the question is that the maximum? It means, can I find anything more than this by changing x1 and x2? Okay. So in linear programming or optimization, we also have some constraints that are hidden, and these constraints are always inferred. And those are non-negative values. All of the variables we use, like x1 and x2 here, not y, because the y is a function of x1 and x2. So y is not a variable. Y is a function of these two, but then these two are variables, x1 and x2. So for x1 and x2, we need to have them to be positive, which means this is called non-negative constraints or non-negativity constraints. Okay, so these are all inferred. The non-negativity constraints are all inferred, but these should be given for any problem. Okay, it's called linear programming because, well, in this section, we only look at problems that are linear in the variables. Like if we have x1 and x2 as the variables, the objective function, which is the function we want to maximize, should be linear in x1 and x2, and the constraints also need to be linear. Like this is linear in x1 and x2, and this is also linear in x1 and x2. And if you want to know what linear means, that's the generic definition of linear in algebra, which means we should not have multiplicative term of the two variables or more. Like we cannot have x1 times x2, or we cannot have x1 raised to the second power or to the third power. So any power more than 1 is not allowed, and multiplication of two variables also not allowed. Like we cannot have x2 times x2 or x2 times x1, right? Everything has to be linear. So that's why it's called linear. And then programming comes from because we need to sort of write a program to find the maximum of this problem or maximum of this function subject to these constraints. So maybe the name is coming from, the concept of programming and dealing with linear functions and constraints, so it's overall called linear programming. The method we're going to talk about today is called Simplex. So Simplex is a method to solve linear programs. Okay, so it's called a Simplex algorithm. And so we don't get to the details of what really Simplex method is, we just want to know how we can solve it in Excel. Okay, so Excel has this package that you can solve any linear programming using simplex method. So very roughly, the simplex method says, if you draw all these constraints, like I can pictorially see what this problem is. I can draw the region where x2 minus x1 is less than 4, right? So maybe from high school you remember how to draw this nonlinear equation in Cartesian coordinates. So let's say I'm going to plot this function, x2 minus x1 to be less than 4. Where is that? What part of Cartesian coordinates or space or 2D space this is going to occupy? So let's look at that. x1 or x2 minus x1 less than 4. So let's write the equation with equality sign. Like I can go ahead and draw x2 minus x1 to be exactly equal 4. If this is my x2 axis and this is my x1 axis, you draw this line. So this is going to be, this line exactly is going to be x2 minus x1 equals 4, not none. So we're not talking about inequality yet. This is when x2 minus x1 is exactly 4. Okay. Now we ask the question, which part of this 2D space, right, would be x2 minus x1 less than 4? Then either on this, either the right side of the line or the left side of the line would be the answer. So let's see which one is the answer. We can easily test a point. Let's say I'm going to put 0, 0, right, the origin. I'm going to plug in there, origin is 0, 0, so plug in 0 minus 0, it's 0, and 0 is definitely less than 4. So this point satisfies the inequality, which means the right side where 0, 0 is included is the answer. So if you want to know where x2 minus x1 less than 4, that should be on the right side of this line, not on the left side. Okay, left side is bigger than 4, right side is less than 4. Let's do one more example. I'm going to draw the second line here, x1 plus x2 less than 8. So first we're going to draw the equality line, which means x1 plus x2 equal to 8. So if you go ahead and do that, so this is going to be the line of x1 plus x2 equal 8, right? You can easily test. The sanity check is when x2 is 0 and x1 is 8, which is this point, should be on the line, which is. And also this point where x2 is 8 and x1 is 0, right? This should also be on the line, which is on the line. So that means the line is correct. So this is x1 plus x2 equals 8. Now which side of it is less than 8? Just plug 0, 0 in there. 0 plus 0 is less than 8, yes, so it satisfies the condition. So 0, 0 should be included. That means the left side of the line is the answer. So left side of this line is in the constraint, and right side of this line is in the constraint. The simplex method says, given that x1 and x2 are also positive, right, these are non-negativity conditions that are always inferred, that means we should be on the top side of x1 axis and on the right side of x2 axis. So that means we should be limited in this polygonal shape, right? In this like four-sided polygon. We have to be on the right side of this line and left side of this line, as these arrows indicate, top side of x1 axis and the right side of x2 axis. So that means we should be surrounded by these 4 lines, right? So the solution should be a point within this polygon, and this four-sided polygon. Now simplex method claims that the solution is one of the corners. So it's either this corner, this corner, this corner, or this corner. Cannot be on the line between the 2 points. So this is a very powerful method. It says if you have a linear programming problem and you find the feasibility of the region to be a polygon like this, which means the points that are feasible to satisfy just the constraint, okay, those points are called feasible region. So if the feasibility region is within this polygon, then simplex method claims that the solution should be on the corners of this feasibility region. Okay, and then simplex method in the spreadsheet is going to test these corners for us. Okay, so we're not going to test all these corners. Spreadsheet is going to do that for us. All we need to know is what simplex method is. All right, so let's look at this problem and try to solve it. So I'm going to put these equations in a spreadsheet. I'm going to see how we can do this and solve it using a spreadsheet. So here's my spreadsheet. I'm going to move it over here so you see both the problems and maybe over there and this one over here. Okay, so I'm going to create two cells for x1 and x2. So these are just the header. These don't have any meaning. I just write x1 and x2 for myself to remind myself that what's going to be underneath this. Okay, so let's say I'm going to start with a guess value. I'm going to guess that x1 and x2 would be, like 1 and 1. So this is x1 and this is x2. And I'm going to guess it to be 1 and 1. I'm guessing that x1 equal 1 and x2 equal 1 maximizes this. I don't even know if x1 and x2 satisfy my constraints. Okay, I just throw in a guess value, and the spreadsheet is going to take care of all of them. Okay, so then I write my objective function. So here's y equals to, and I implement objective function in here. So if we look at the equation, it's 2 times a2, which means 2 times x1, and then plus 4 times b2, which is 4 times x2. So here's the objective function in here. So I wrote the equation or implemented the equation into this cell that I just highlighted. Okay, so these are the notes. These are just comments for myself. The bold ones are just comments or header or anything that spreadsheet doesn't care. The numbers are important. So this is the value of x1 that I guess. This is the value of x2 that I guess. I implemented the objective function into this cell, and then I have to implement the objective function into these two cells. So what is the objective function? Sorry, the first constraint. So we're going to write only the left side of the constraint. We don't write the right side of the constraint. Okay, always the left. So it's going to be x2 minus x1, which according to the spreadsheet is going to be b2 minus b1, because b2 is x2 and, sorry, a2 is x1. So it's going to be b2 minus a2. Fine. The second constraint is x1 plus x2 less than 8, which means b2 plus a2 less than 8, right? So I just write the left side, which is b2 plus a2. That's it. Okay? So far we wrote the objective function, we wrote the left side of the constraints, and now we're going to solve it. And we start with the guess value, 1, 1. So then we're going to go to solver. You go to data ribbon on the top. In Mac should be in data. In Windows, if you find your data ribbon, it's exactly right there. It's close to what if, where we use for goal seek, right? We use what if. We use what if for goal seek. Now we're going to use solver, which is another button next to what if button. So I'm going to click on that. It opens a menu for me. It says, what is the objective function? So I give the cell location to the objective function, which is this cell, right? It's B3. This is what I implemented, right? Remember again? Let me just cancel that guy. So this is the objective function, right? 2a2, which is x1, plus 4b2, which is x2. Okay, then I go to solver again. The cell I'm going to optimize is B13. It's this cell. Sorry, B3. Right, this is B3. And then it says you want to maximize or minimize. So I'm going to maximize. I'm going to click on maximize. It's a maximization problem by changing which variables? A2 to B2. So here's A2 to B2. So these are the cell ranges that I want to change, which means this cell and that cell both. And then we're going to add the constraints here. Okay? So to add the constraint, you just click on the add. And you say which cell need to be less than or greater than or equals. We have a bunch of different constraints here that we can use, and then you say what the constraint is. And then you click OK. Okay? So in the next video, I'll show you how you can complete these constraints and basically solve the problem. So stay tuned and thanks for watching.